Chapter 11 is all about finding surface areas, and 11.1 is area of parallelograms. So area of parallelograms. Before we begin, we just want to review, area of rectangles, of course, is base times height, so long as base and height are perpendicular. Well, it turns out the area of parallelograms is very, very similar. Here we've got a parallelogram, its base. Now the height of the parallelogram is the perpendicular distance between the two bases. So area here is also base times height, except height is a little bit more difficult to find. So let's look at an example. Let's say we have this parallelogram. We've got a 60-degree angle and a base length of 32, and one of the other sides is 24. We want to find the perimeter and the area. We know opposite sides are congruent, so BC is 24, AB is also 32. Then if you think about the triangle made from BC and then its height, since opposite angles are congruent, I know I've got a 30, 60, 90 triangle. And if that length, the hypotenuse, is 24, I know the short leg is 12, and the long leg is 12 root 3. And so that means the height of the parallelogram is 12 root 3. So the perimeter is two sides of 24 and two sides of 32, which gives us 112 inches. And then area, base times height, I'll take 32 times 12 root 3. Now remember, when you're multiplying, not adding, but multiplying with square roots, you can multiply in any order you want. And so if I want an exact answer, I'll multiply 32 times 12 and leave the root 3 sort of tacked on at the end. Make sure you label as square inches. Next example. Find the perimeter and area of this parallelogram. So again, kind of using that special right triangles idea. We've got this 45, 45, 90. And so if the n root 2 side is equal to 5, that means n must equal 5 root 2 over 2. And so in this parallelogram, base length is 5 root 2 over 2. The height is also 5 root 2 over 2. And so the perimeter, two sides that are 5 and two sides that are 5 root 2 over 2, that simplifies down to 10 plus 5 root 2. And if I asked for an exact answer, I would leave it alone. You can't simplify that anymore. And then for area, again, is base times height, 5 root 2 over 2 times 5 root 2 over 2. Now remember, when you're multiplying fractions, you multiply the tops, you multiply the bottoms. And 5 root 2 times 5 root 2 is the same as 5 times 5 times root 2 times root 2. So we eventually get something like 25 over 2 square meters. Next example, here we've got a quadrilateral, FROG, and we're asked, is it a parallelogram, a rectangle, or a square? So this is kind of a review question, but part B will be a little bit more geared towards chapter 11. So first, let's graph it. Kind of looks like a rectangle, but let's verify, let's check to make sure. We'll use slopes. So slope of FR and OG, and FG and RO. I see the slope of FR is negative 1/3. Likewise, OG is negative 1/3. FG and RO both have a slope of 3. Now, since FR and OG have the same slope, that means they're parallel. Likewise, FG and RO are parallel. But then also notice that, say, FR and FG are perpendicular. because their slopes are opposite reciprocals. And so that means we know for sure that FROG is a rectangle. Now it doesn't look like a square, but to verify algebraically, we could find distances, find the lengths of corresponding, consecutive sides. So FR I see is 2 root 10, FG is just root 10. So clearly it's not a square, it is indeed a rectangle. Now, find the perimeter and area. Well, perimeter, I know from the previous that the short side is root 10 units long, the long side is 2 root 10 units long, and so perimeter is 2 sides, root 10, plus 2 sides, 2 root 10. And then area, remember area is base times height, and in a rectangle, that's just length times width, so 2 root 10 times root 10, and that simplifies down to 20 units. 20 square units. Our task here is to find the perimeter and area of this irregular polygon. Let's first find the perimeter. If all the angles are right angles, then if this top side is 6, I know we can turn the whole thing into a rectangle with a bottom length of 6 and a height of 3. Now, using the information that and so we can say the perimeter there is 18 units. To find the area, we'll break this figure up into rectangles and squares. First, we see we've got a 1 by 1 square, so the area there is equal to 1, because 1 times 1, of course, is 1. Next, we've got this other square, and I know that it is a 2 by 2, and 2 times 2, of course, is 4 square units. And then lastly, we've got this 3 by 3, and of course 3 times 3 is equal to 9. So that gives us an area of 14 square units. With this next example, there are a bunch of different ways to figure out the missing side lengths. Here's one way. So we know that this top length is 12, and so since all the angles are right angles, I know this length is also 12. However, if this business down here is 4, that means this is also 4 from here to there, and so the leftover piece has to be 8 units long. Then we also know that this entire length is 10. This little piece is 2, and so the remaining bit has to be 8 units long. Now over off on the far right, we know this length is 6, but this little piece is 2. And so that means this little portion is 4, and so therefore this little space is also 4. So we have 2, 4, and then the unknown here would have to add up to 10, so this piece should also be 4. And so then our perimeter is 10 plus, oops, forgot a piece. If this is 4, this has got to be 4 up top here as well. So perimeter is 10 plus 4 is 14, 16, 28, 34, 38, 40, 48, 52, and 56. Then to find the area, we can again break this up into simpler shapes. We could first look at, well, let's say this rectangle off on the far left is going to be a 10 by 4, so that area is 40 units. This rectangle next door, we could say was, well, what was that, 8 by 4, and so that's 32 units. And then this rectangle, we've got 4 by 6, which is 24 units. So add them up, 24, 32, and 40 gives us an area of 96 square units.